So let's start. We are in week 10. Today we'll be talking about the database and how you can integrate a database. And with that, we'll also play a little bit with table view and dynamic cells and all that, right? So let's start another playground. One more time. Let's start a new project. Single app view, single view application. Lab 10. Okay, we have our application created, our project created. Let's start building the UI. I will start doing that and then leave you a few minutes to continue to catch up. What I want to do, I want to have right now 2 screens. At the end, I want 3 screens. One will be a list of items, let's say students or cars or whatever you want to store in the database. Second will be showing details. And the third screen will be edit screen or add screen, right? So let's start with the navigation view controller. Here it is. I will move things around. Right, you remember the arrow. I want the navigation view to be my entry point. What we'll do, we'll open the database in the table view. We'll open the database in a table view controller, load whatever is in the database, present in the table view, and when we click on the cell, we'll go to the next one, and this will either display the element or will allow us to edit the element. Okay. So let's take a look at the table view first. Let's select the table view, and what we want to do, you see that what is selected right now in the table view, in the content, the type is dynamic prototypes, and that's what we want to use today. What we want to change is the style for the table view cell. The default is custom, and it's blank right now. You can build it yourself, right? But what I want to use basic, right, with the title. And we can add also the accessory, right, the disclosure indicator, showing that there is something more when we tap on the item. To be able to work with this more, to be able to implement something, we need to add a new class, right? So I'm going to File, New, and File, and I will add a CocoTouch class. This will be child of UI table view controller. I will leave the name table view controller. It's clear what it is. There will be only one in this application. Next, and create. All right, so this is my class. I will come back to it quickly in a few minutes. But first, I have to go back to my to my view, to my main storyboard, and I have to associate this new table view with this screen, right? So that's what I'm doing right now. You have to go to the identity inspector and in class, make sure that this refers to this. The next step that I want to do here is make sure that the table view, the table view cell is leading us to the detail view, right? So to the one that is blank right now, and it's called view controller. And we want to use show. Let's put some ID on this connection, on this segue. Let's call it show. There's one more ID that we have to set, and it's for the table view cell. If you you click on the table view and on attribute inspector, there is a field called identifier. The hint in a gray says reuse identifier. We need to name it somehow. Let's call it cell. Short, hard to mistype. We'll need that that element. Okay, so let me do just one thing. I will increase the size of the font. Because right now we'll switch to the code. Let's start with the database. We'll be using SQLite. To have access to those classes, we have to import SQLite 3 module. This whole module, this whole library is based on C, and you will see that pretty quickly in terms of the way how you work with it. What we'll need to store on the class level is a reference to the database. And the type of this reference to the database is very intuitive. Opaque pointer. Told you it's intuitive. This is a pointer to a structure. And we'll use this opaque pointer in a few incarnations in this code. One is a database, another one will be statement. Anything that is actually coming out from the library will be sent as this. Right, so we'll work with. We are not really working with classes. We are working with structs, with structures. When we load our view, sorry, we want to open the database. And to do that, first we need to make sure that we have a file where the database is stored, right? So let's do that. let file be equal to try. Very ugly try. You will see why in a second. File manager. We're getting a default file manager for our application. They're telling that we need a URL. We want to create a file in a document directory, in a user domain mask. So this is our file. We can say that this is Neil. And we need to create it, right? We don't have the file. Sorry, no, this should be false. Because this path exists. What we want to add is the path component with the name of our database, too many quotations. Database DB. So we have a file. Now it's time, going back to the try. I told you that it's an ugly try. And you see why? There is no catch, right? There is no information. We are trying this and hoping that everything is correct, right? If it's gonna crash, it's gonna crash. This is simply making sure that we can execute the line without really any method to recover, right? Okay, so let's open the database. SQLite 3_open. This method gets the file and gets file.path. And gets a DB, but it gets a DB in a very specific way as an output parameter. Now, if this method returns something else than SQLite OK, it's a trouble. We have a problem. So right now we'll simply log the information, right? Error opening database. Otherwise, we can move forward. And what we can do, we should try to create a database now. Right? That will be another if statement. and we'll use exec function. This exec function, again, will take a DB, and it will take a query. This query I will define as a variable, right, or as a constant, actually. Let create be equal to the following string, right, and we'll use create here. So create will be as follows. Create table if not exists. What do we want to store? Students, cars. We'll have cars. Car will have ID. Will be integer. Primary key and auto increment. We'll have a plate or make. It will be a text. What else? Price. Integer. I think it's enough. So this is my query. There are a few other parameters that we don't need to set for this query. We have 3 nils. You can pass extra information, right? You can pass some additional parameters to the query. Right now, if this is okay, then it's okay, and we have a new database. If this is not okay, then what we can do, we can get the error from the database. Because this is C-based library, they return a different type, so we have to do the conversion. SQLite3 error message. For the database. And if we have this, then we can print the information, error creating DB. We can print a message. So at that point, we should have the database created. And what I would do right now, I would test this code, right? So I will open the window on the bottom to see the log, and I will run this code. If that works, then we are safe and we can continue. Okay, so application started, no errors, nothing in the output. We can continue. The next step will be adding some elements to our database, and I will have a function that will quickly add just few rows. That I will use it once, and then we'll create a window that will add elements. Okay, so we'll have a function add sample, no parameters, no return type. We'll just sorry, write the code. What we need to do, we need to create a query first, right? It will be an insert. Insert into cars. What did we have? We had make and price. Values. These two values will be replaced right now by question marks. Now what we have to do, we have to create the parameters for this query and execute the query, right? And we'll just generate values, right? So it will be car 1, car 2, car 3, and the values will be also generated the same way. So first we have to create a statement. Statement, as I said in the beginning, is opaque pointer, the structure, SQLite, P, prepare. Prepare will take a database as a first parameter. Then the second parameter is the query string. In our case, it's insert. -1 for the third parameter. Fourth parameter is the pointer to the statement. So this is the output parameter for this function. And then tail, I don't remember what this is, but we are not using it. If this is okay, then we can continue. If it's not okay, then it would be nice to see what is the error. Right, so we'll print the error. And actually, we should finish if this is an error. Right, so we should do return. But if we successfully created the statement, we can bind values to the statement, and we'll do that in the loop. Right, all that should be in the loop actually. So for I in we add 10 elements. Each time we'll have to prepare the statement and bind new values. If SQLite free underscore. Well, we have different versions of the bind function. In this case, we'll be using text and int. First parameter is a statement. All right, so this is stmt. The second parameter with the bind, it tells us which field it is. In this case, it's the field with number 1. There's actually a second field in the whole table, right? Second column. We need to provide a value. Say car -1 and nil. Again, it can fail. It can fail, right? It can return something else than SQLite. Okay, and we have to see what's the problem. Binding make. We have to do the same thing for the second element, which is the integer, right? The price. It will be SQLite bind int. Again, statement as a first value, second value is the number, the third value is the actual value that we want to add there, right? And we'll have to convert it. After that, we have the statement ready for execution. Name the function that we'll use to execute the query is another very intuitively named function. It's called SQLite 3-step. This function, if it's successful, returns what? No. It returns a value, a flag, SQLite done. right? If it's done, it's done. If it's not done, then again, we should try to figure out what's wrong. Right, this function does not return a cursor because this is insert. I know you can forget that this is insert after writing that code, but this is insert, so we just get the information that it's done, right? Let's call this function, and as I said, we'll do it just once, and then I will comment it out. Okay, no errors. What I will do right now, I will add a class that will be my representation of a row. Right, so I will add a new file. In this case, I'm not selecting Cocoa Touch. I will just select a Swift file. Actually, I should name it somehow. Let me do it again. New file, Swift file. I will call it a car because that will be a representation of the car. I will create a class car. No need for the superclass. In this class, I will have ID. That will be an integer. I will have a make. That will be a string. And I will have a price. That will be also an integer. I'll have an init function. Right. And a very simple init ID equals ID. Make is equal make. Oh. I will use this class in my communication later on. Specifically, I will have a variable here called cars, and this will be an array of cars. Right, so I can actually initialize it here. I will also do, I'll add a function read values. What this function will do, it will first clean the content from cars. We'll call remove all. And then it will query the database and fill in the array with the new values, right? Not the most effective way of doing it, but very, well, not very efficient, but effective. Let's put it this way, right? So first, let's define the query. Select star from cars. We'll need a statement. We'll need to prepare the query, right? So again, we go down to our add sample. We have this function here, the whole if statement. Let's use it. Instead of insert, we'll have a queue. And now, in the loop, we'll read our database. And that's another funny thing. SQLite _step can return something else. Can return done, but it can also return SQLite row. And if it returns row, it means, if it returns this value, it means that there is a row to be processed, right? Again, the same function used with different queries returns different flag, and based on the flag, you can recognize what happens, right? If it's a row, then we can read from the result, right? And we can create an ID, SQLite _column int statement and the column index 0. And we'll have sorry, we'll have make. Make is a string. Again, from the library, we'll get a C string. SQLite column text. Again, the statement is the first parameter, and the index is the second parameter. And the last one is price, that we store it as an integer. SQLite 3. Okay, so we have our values. Now we can create our car instance. ID, make, and price. And we can add car to the list. Oh, sorry, C. And use the proper language, right? What's the problem? The problem is, of course, with the integers. What we receive is not int, is int32. That should resolve it. Sure, if you ask, it could be one long line, but this way it's easier to debug. So we load it, right? If we call this function in view.did_load instead of @sample, our values will be brought into the controller. Now, how do we display it? There are a few functions that we will have to uncomment or modify. Number of sections is the first one. We'll have one section. We know that, right? Number of rows, well, we don't know, but we know that we have this array that notes how many rows we have, right? And then this function table for cell for row at index path. This is a function that takes the template based on the reuse identifier. We said it's cell, right? And we can display something. What we can display? We can say that the cell got text label dot text is equal to the make of our car, for example, right? So we can get cars index path dot row, and we can take a make. We run our code right now. We have our cars. Of course, if I click on any of them, nothing happens because I didn't do any communication with the second view, right? And there is no design in the second view. In a similar way, you can remove elements from the table and call other queries. Okay, now if we go to the view controller, to the second view, remember how we implemented the communication between controllers? with a variable, right? I can create a variable car that is optional, right? And I will pass the information to this variable. So let's create design for this view. Need it a little bit bigger. We'll have ID. We'll have make. And we'll have price. Let's create outlets for those labels. ID text. Make text. And price text. We have this. We can load the data, right? So we can say if let's see equals car, right? So unwrapping the car ID text dot text is equal to c dot ID, right? And I can do the same thing with make. And I can do the same thing with price. Right? Price text is equal to okay, the question now is, how do we know which element it is, right? So I'm going to the table view. And I'm going to the bottom, to the navigation, because that's where we'll be playing with that, right? First of all, we'll check if the segue that is called is the show segue. If it is, then it means that the destination controller is equal to segue.destination, of course, but it also means that it's a view controller. I know this is my class. We also know that there is a function that returns a value of the index of a selected row. And to be honest, I don't remember the name of the function. I think it's from table view. Index path for selected row. That's the value. Okay, so if we have this value from the list, we can select parse. From the list, we can select the proper row. And this is actually the value that we want to pass to the dc.car. If we test, we have our data passed to the next view. Okay. Let's do another thing. Let's go to the storyboard, because we want to add new row. And because we want to add new row, I want to add a new item here. And I want to be able to, I will create a new view controller. Right. So first, bar by button item. I'm dragging it to the table view, to the navigation bar, the top. And I will modify this. There is this field called system item that is set to custom. I will change it to add. It will turn it into a plus button. Next, I will add new view controller. Move this one lower and add a new screen here. And my button will lead to this one, right? And identifier for this one will be add. We'll need some labels. Make price. And we'll need some text fields. Keyboard type, use number pad for this one. Let's add a new class, Coco Touch, UI view controller, add view controller, and let's set it, connect it with the with our new controller right away, right? So identity inspector, and we are selecting the class, right? Now we can start editing this this class using the assistant editor. Because what we need to do, we need to create we need to create the outlets for this two text views, right? So it will be make text, and it will be price text. I'm not using ID because ID is auto increment, right? So I don't let user to select the ID. It is generated by the database. What else would be nice? The save button that I didn't add, right? We could do it in a different way. We could do it on exit. Let's add the button. Add. And for this one, we'll need action. All right, action, add bar. If we test this, we should be able to see a new screen. Right now, nothing happens, right? Okay, so what do we have to do? We can do two things, actually. We can either grab the information and pass it back to the previous controller, or we can implement the whole thing here, right? Definitely we'll need the code to insert our new element, right? So let's try to implement adding in this view, but we'll pass the reference to the database, right? So this one will have var db opaque pointer. Right? So obviously, when we go to the table view, right, into the navigation, into the prepare for segue section, we'll have else if statement checking if segue identifier is equal to add. Right? If it is, then our PC will be equal to segue.destination as add controller, and then PC.db. I'm very creative today with the names. is equal dv. So we have open database connection. We are passing it to the second class, right? Second controller. And then in the add view controller, we'll do what we did in the where is this function? Read values in here, right? We'll need a insert. We won't need the loop, but everything that is in the loop will be needed. Right, add car will be here. I don't need the for loop. And one thing that I forgot to add is the import. Import SQLite3. Right, so I have an insert. I will fix the bind statements in a second to resolve those issues. Because before I can do that, I need to grab the values from the user interface, right? So what I will do, I will create a variable that will be a car, right? And I will use it later on. Before we do that, let's read our make from the user interface, right? There is make txt dot text, and then the second one is a price. Right, so it's a price text dot text dot it's int, right? We want to do the conversion. Let's see, b equal car. No, we don't have ID, so we cannot do that. But we can bind it directly here, right? So bind car, this is our make, and this is our price. Yes. Another error somewhere here, because this is optional. And 32. And we have to do casting to the types that they expect. Okay, so this will add element to the database. At least we hope that it will. Let's take a look at errors. No issues. No errors from our side, right? But if I go back, I don't see my, right? If I rerun my application, then there is a new car. What do I need to do? Any idea? What did, if you recall, Android, did you have situations like that in Android? What happens? Let's start there. What happens? In this situation, right? I'm adding something to the database, right? And then I'm going back to my list view or table view or whatever, right?
Because that view, if I'm not mistaken, isn't getting reinstantiated when you go back. It's just sitting in the background. But it needs to be reinstantiated.
Exactly, right? The simplest way to do it, I don't know if it's the simplest way, but it is a simple way. There is a function you it appear or will appear. Either of them would be good. What we can do, we can call read values. One more time. And then table view dot was then the second function. Totally forgot. Give me a second. I will find the name. Reload data. Right? These two calls will first read a new set of data from the database, and the second one will reload, refresh the view. Right, so if I add here, that's 2. That's my new element, right? If I don't like this behavior of the add view, what I can do at the end, I can either clear the content of the form, right? So I can say here, else make txt.text empty and price txt.text empty. That will allow me to add the next one and the next one and so on. Or I can simply say dismiss, right? And it will go back. So I like to have ability to add more than one car at the time. All right, if we test this. We have new elements added. Do you have any questions about this? How do you like the library? I don't know about you, but I don't. Like I don't like the style. I don't like how it's implemented. Because it's so different from what you're doing, right? You're working with object-oriented language, and now you're switching to something that is totally different. Right? It's C-based. It's based on structures. Totally different paradigm, right? And this code looks ugly. Right? It would be nice to wrap it in something that is object-oriented, object-based. But anyways, that's how you work with it on this side, and that's why you have the core data library that is object-based storage, right? That you can work with. I think that's all for now. I will stop the recording.